question. Now, students, in this class we will be studying about the rational root theorem. So we are given a polynomial of degree 3. Now, in short, what is this rational root theorem? It is nothing but guessing the root. Okay, that's all. That is what is the real meaning of this theorem, rational root theorem. So how do we guess the roots? So foremost, you have to consider the constant, okay, and find all factors of this constant. So that would be plus 1 to start off with, minus 1, plus 2, minus 2, plus 4, minus 4, plus 5, minus 5, and of course you have got plus 20, minus 20. And then you find all factors of the first term, the highest power, okay. So in this case the coefficient of x to the power 3 is 1, so the only factors would be plus 1 and minus 1. So having obtained these, we call this first line as P and the second line as Q. Now what you got to do, you have to find all combinations, okay, so all combinations of P over Q. So I can have a plus 1 and plus 1, plus 1 and minus 1, and then I can have plus 2, plus 1, minus 2 and plus 1, plus 4, plus 1, minus 4. I don't have to place minus 1. If I place minus 1, it's going to be 4 divided by 1. That's what I have got already. So place 1 there, and then plus 5, plus 1, and minus 5, plus 1, plus 20, plus 1, and minus 20, plus 1. So these are the possible factors or possible roots, I should say, that can be placed into the polynomial. And the outcome, if I were to take this as p of x, then one of these values will produce me a 0. Okay, so that would be the root. Now the question is, this is just a guesswork, okay, so what you got to do is, if you are going to be rewriting this, so this is going to be 1, minus 1, plus 2, minus 2, plus 4, minus 4, plus 5, minus 5, plus 20, minus 20. So these are the possible roots that can produce a root for the polynomial. So if I were to take p of x to be as x to the power 3 negative 5x squared negative 4x positive 20, I substitute the first value, I get 1, negative 5, negative 4, positive 20. Clearly it's not equal to 0. And then I move on, taking the next value p of negative 1. This is going to be negative 1, 5, negative, right? So that's going to be positive 4 and positive 20. Clearly this is also not a root. And then if I were to substitute p of 2, that would give me 2 cubed, negative 5 of 2 squared, negative 4 of 2 positive 20. This is 8, 4, negative 20, and this is negative 8 and positive 20. So positive 8, negative 20, positive 20. So I'm getting 0. So p of 2 I am able to obtain a 0. So this would mean x minus 2 is a factor. So if I were to use synthetic division, okay, x is equal to 2. So let me write down the coefficients of this polynomial. So the first one will give me 1. Second one is negative 5, followed by negative 4 and 20. I bring 1 down. 2 times 1 gives me 2. I add these two together, so that gives me -3, -6, and -10, and this is going to be -20. So this is clearly 0. So the remainder is, or in other words, the quotient is x squared. We started with x cubed, right? So that's why I'm writing it as x squared, -3x, -10 equal to 0. So now I can use the quadratic formula. A is equal to 1, b is equal to -3, c is equal to -10. X is equal to -b plus or minus root of b squared -4ac divided by 2 times a. This would give me negative of -3 plus or minus -3 squared -4 times a times -10 divided by 2 times a. So I'm using the space here. So this is going to be +3 plus or minus root of 9 +40 divided by 2. So that's going to be 3 plus or minus root of 49 divided by 2, which is 3 plus root of 49 is 7 divided by 2, 10 divided by 2. This would give me 5. Okay, or 3 -7 divided by 2, -4 divided by 2. This would give me -2. So therefore the roots are, I start with -2, I have a +2, and I have a +5. So I have achieved the objective, that is to obtain the roots of the given polynomial. Okay, so what did I do? I used this theorem, rational root theorem.